Hey guys, I am so sorry I'm out again with a sick kiddo. Um, Today we are going to work on applications of quadratics. We're going to do two different types of applications. So take a moment to pause this video and think about this teamwork. So if you look what I've done here, it asks you to draw a rectangle and you had 20 yards of fencing. So that would indicate perimeter. So I only asked you to do one, but I drew two different rectangles with a perimeter of 20. And what I want you to notice is that the areas were different. And so one of the applications that we're going to do today is maximizing or minimizing something, one of which we're going to do is maximizing the area. So let's look at this example. So go ahead and pause this video and make sure that you write down the example. And here we go. Okay, so you have 100 yards of fencing to enclose a rectangular region. Find the dimensions of the rectangle that will maximize the enclosed area. What is the maximum area? So if you think about maximizing and minimizing, and what we've been doing with quadratics is that your vertex is either a maximum or a minimum. And so that's how it is all related to what we've been doing. So let's start with a rectangle. And we know that a rectangle has some length and some width. And we are given this 100 yards. So we know the perimeter is going to be 100 yards. But we've got perimeter is 2 times length plus 2 times width. Now, if we let one of those variables, either length or width, be x, we can write the other dimension in terms of x. So we want all of our sides to be in terms of x if we can. So if we have perimeter is 100, and if I let my length be x instead of L, what happens now is that I can solve for W so that I have the width in terms of x. So to solve for W, I would subtract and then I would divide. So if I'm going to divide every single thing by 2, and I've got W is 50 minus x. So if the length is x, the width is 50 minus x. So I'm just going to rewrite this down here just so that it's more clear as to what we're looking at here. Okay, so what we have been asked to do is to maximize the area. We want to know what the maximum area is. So if you look at this rectangle, we know that area is length times width. So perimeter was 2 times length plus 2 times width, but area is length times width. So our area in terms of x is x times 50 minus x. And we can distribute that x and put this in standard form. That's not quite standard form yet, so I'm going to rearrange that. So we have this quadratic with a negative leading coefficient. If we were to graph a quadratic with a negative leading coefficient, we would have a parabola that opens down that has a vertex as a maximum, which is really convenient because that's what we're trying to do, is maximize the area. So if we find the vertex, that's going to give us the value of x, and the area, that would be the maximum. So there's two different ways you can do this. Because it's in standard form, we can do opposite b over 2a. and then plug that in. But if you are a fan of completing the square, you could also complete the square. So I want you to pause the video for a minute and go ahead and find the vertex. All right, so hopefully you have had the time to find the vertex. I found it both ways of here's opposite of b over 2a, plug it back in to find the y. So I got a vertex of 25, comma 625. Option number 2, I completed the square, giving me, remember this lies, this tells the truth, so h is opposite, k is the same, so I got the same vertex, 25, comma 625. Okay, so what does that mean? That means that if I go back to this rectangle, okay, and I were to put 25 into here for x, this side would be 25, this would be 50 minus 25, and that would give me a length of 25. So the side length of 25 by 25 would give a maximum area of 625 yards squared, or square yards. And that's true. A square is going to maximize area, but we're not always going to be dealing with the exact same rectangle or square or something like that. But anyway, so another way we could do this is to put the quadratic into your calculator. So this will be on the calculator portion of your assessment. So if I put this into y equals and change my window to this, pause this video, type it into your y equals, change your window, and then what you're going to do is you're going to go into this calculate right here, second trace to calculate, and you're going to calculate a maximum. And when you do that, it should verify that the vertex is at 25, 625. Okay. So now, if you could, pause the video, write this problem down, and talk about it with your team before continuing. Okay, so take a look at my picture. What's different about this one is that we're enclosing a rectangle along a river, okay? And so we're not going to fence one side of it. So we have 200 feet of fencing total for 3 sides. So if I just made this side x, this side is also going to be x. That means that this side is going to be the total perimeter of 200 minus these 2 sides, so 2x. So take a minute to pause the video. Remember, area is length times width of this rectangle. That's what we're trying to maximize. Write your quadratic, find the vertex to find what length is going to maximize the area and what the maximum area is. Okay, so this is the quadratic that you should have gotten, and now it is up to you to find the vertex. Do you want to do opposite of b over 2a? Do you want to complete the square, or do you want to use your calculator? And I'll tell you that using the calculator will be a little bit time consuming because you have to figure out what window is going to work, and sometimes that can be a little bit challenging, and sometimes you guys can just do the algebra faster. So pause the video and find the vertex. So I got a vertex of 50, 5,000. Okay, so what does that mean? That means that if I were to look at this parabola, my vertex would be at 55,000. That would be your maximum area. If this side length was 50, this would be 200 minus 2 times 50. So this is 100. So your dimensions would be 50 feet by 100 feet, giving you a maximum area of 5,000 feet. So if you looked in your calculator, I used this window. All right. So can you have an area that's 4,800 square feet? Yes, that's less than your maximum. So here would be your 4,800 square feet. So there's actually two different possibilities for that. You could find that algebraically by just plugging in 4,800 for A right here and then solving your quadratic by one of the four methods that we know to solve for X. That would give you your two different values or lengths for that side. Okay. So we have one other example we're going to do. And I'm going to leave you with this teamwork, but I'm going to do this example. So pause the video and write down that teamwork. And then I'm going to move on to this next example here. Okay, so we have maximized the area. You just wrote down an example and did with your team minimizing something. The only difference here is that you're going to get a parabola that opens up. You're finding a minimum there. Okay. Do this real quick. So if you let x be number 1 and y be number 2, it says their difference is 10. So x minus y equals 10. And you want a product to be as small as possible. Product means multiply. So if we want both numbers in terms of x, we would solve this for y. So we would subtract x. We would divide by -1. And we now know that y is x minus 10. We've also got x. So if you wanted to minimize their product is x times x minus 10. So you're looking at x squared minus 10x. Notice it does open up. When you find the vertex of it, that is the minimum. That's the value of x. So then you would also get the corresponding value of y for the second number. Okay, so let's look at this second type of application. It says in a sleep study and death rate, or I'm sorry, in a study relating sleep and death rate, the following data were obtained. Use the function given there, just the standard quadratic, to model the data. Okay, so what we're given here is 3 ordered pairs. And if you look at the quadratic, we know x and y. What we don't know is A, B, and C. But because we have 3 different ordered pairs, we are going to be able to find A, B, and C by plugging in 4 for x, 1682 for y, and then do that with our other corresponding ordered pairs. So in this particular case, 1682 is your y, 4 is your x. Okay, so if we simplify this, 4 squared is 16. So this is just 16a squared plus 4b plus c. Okay, let's do that for the second ordered pair. I'm going to get a different color here. It's not wanting to do that for me. There we go. Okay, so now x is 7, y is 626. Okay, so 626 is your y, ax squared. Well, now x is 7, so 7 squared. Bx, so b times 7 plus c. So if I simplify that, I've got 626 equals 7 squared is 49. So we've got 2 equations there. Now we just need one more. So I want you to pause the video and try this third ordered pair. Okay, so plugging in 967 for y and 9 for x, we obtain this third equation. If you think back to systems of equations, okay, linear systems of equations, you had things like x plus y equals 7 and 2x minus 3y equals, I don't know, negative 10. And you could solve this by graphing, you could solve it by substitution, you could solve it by elimination, because you had 2 equations with 2 unknowns. Well, now we have 3 equations with 3 unknowns. We could solve this by hand, but we're not going to. This is also going to be on the calculator portion of your test, so we are going to use the calculator. Okay, and the calculator function that we're going to use is the matrix function. Okay, so we're going to build a matrix where this is A, B, C, and then if you kind of visualize this is your equal to some value of D, okay, or a Y, whatever. All we care about are the coefficients because we know we're solving for a squared, we know we're solving for b, we know we're solving for c, okay? So all we're doing is putting the coefficients in there. So 16, 4, this implied 1 equals the 1682. Okay, next one. 49, 7, this implied 1 equals 626. Third one. 81, 9, and this implied 1 equals 967. You put this into your calculator in the matrix function, it's going to ask you what dimensions it is, okay? And it's going to ask you rows by columns, okay? So this is 1, 2, 3 rows by 1, 2, 3, 4 columns. We're going to put these numbers in there just like this, okay? So let's take a look. And if you notice this matrix button right here, it's in blue, okay? We're going to go second x to the negative 1 to get into matrix. We want to edit, so we're going to arrow over to edit. We're going to press enter on number 1. Remember we said this is a 3 by 4. 3 rows, so 3, enter, by 4 rows, enter. And you see that it does have 3 rows, 4 columns, just like our matrix has. So take a minute to pause the video and type those numbers in. All you have to do is press enter to get through the matrix. So when you are finished, it should look like this. Okay, so now how do we solve it? So go ahead and quit. You need to get out of this. So second mode, that gets you to quit. Okay, we're going to go back into matrix. But this time we're going to go over to this math because we're going to do some math with it. Okay, and if you arrow down, what you're going to see is this RREF. It's called Reduced Row Echelon Form. That's what that stands for. And it actually solves this system of 3 equations for you. So we're going to press enter on B. And then we have to tell it what matrix we wanted to solve. So we're going to go back into matrix. We're going to select, because now we're on names, we're going to select matrix A. So we're going to press enter. You can close your parentheses, enter. And so what this is telling you, remember this was A, B, and C. So it's telling you 1A is 104.5. 1b, or just b, is negative 1501.5. And then your 1c is 6016. So these are your values of a, b, and c to write your quadratic. So write a quadratic in standard form. Pause. So pulling from my calculator, remember that was a, b, and c, those three numbers that were given to us. So y equals ax squared plus bx plus c gives us this quadratic to model this situation. You could always use that model if I asked you other questions, but that's it for today. Okay, you should have a worksheet from the sub. Please make sure that you are using your time wisely, and I will see you guys. Some of you, yeah, I'll see you Monday.